So today we're gonna do a very important and interesting Verilog problem, and this Verilog problem is actually coming from directly from your HDL bits. This is the problem. And if you haven't seen my previous 30 days of Verilog code, then really recommend you go there, watch those, because those actually the basic block, building block for your Verilog coding. But if you know already Verilog coding, you have done something, then you can directly continue from this video also. In this video I am taking this, but actually we already have done this all problem already. And to see those, you can just visit my website called www.whyRD.com, and there, after going there, you can see Verilog practice series 2, and you can subscribe for that to see all this problem, all above problem, and also the problem which is gonna come in the future. So this is a very nice problem because here we will know a lot of things. First of all, let's concentrate on the description, what we gonna do here. So here the important thing is that you gonna appreciate what we design FSM, and this is a real life problem. So here what they are telling, and that is you have a water reservoir here, and you have 3 sensors as your input, right? Now what does those 3 sensors are doing, and actually this is your water level. So anytime my water level below S1, then none of the sensor will be high. Okay, anytime I reach here water level reach here, that time your S1 would be high, but your S2 and S3 would be 0 because water haven't reached there yet. And likewise, if it is here, so 2 and 1 would be high, and if it is above S3, then all the 3 sensor would be high. So they have also given you the tables here, and yeah, and also for the water flow, how the water will flow. Okay, so the thing is that this is your S1, S2 and S3. So anytime I am below S1, if I am below S1, none of the sensors are active, so that time all the water flow, like we have 3 tap, you can assume, so all those 3 tap would be on to fill up the water reservoir. Okay, so we will have F1, F2 and F3, all would be on. Anytime you are in between S2 and S3, so now here it is not straightforward, and that is if you are between S1 and S2 and you are rising your water level from below, like from S1, you are filling up your water reservoir from below S1 till in between S1 and S2. So if this is the case, then for sure your S1 sensor will go high, right? Because water reached that level, and you will open only your F1 and F2 tab. But the trick is that if you reach this position and the earlier stage your water was above S2 and your water got depleted from this level to this level, then we will open, for sure we will open F1 and F2, but also we will open another supplementary water flow which is called delta F, right? So this is like you are at the same level, water is at the same level in between S1 and S2, but according to the situation or according to the previous sensor read, if I am going from this position A to B, right, then previously your sensor, all 3 sensors were 0 0 0, so then you will only open F1 and F2. But if you are reaching from point C to B, then previously your S1 and S2 were high, so that time if you will open F1, F2 and also your delta F. Likewise, if you are in between S3 and S2, right? So these details are there in this statement, you can go through and you can understand it, but I have just given you a summary. Now anytime you face such kind of problem in FSM design, the majority of the task is done anytime we decide on the states, how many states we are having. And yeah, encoding is easy for us because there would be minimum state in this problem, but yeah, deciding on what is the state is the main work actually. And then you need to decide what are the input, what are the output. So here output would be the signal to your taps that hey, F1, F2 need to be open, F1, F2, F3 or delta F need to be open, so that would be your output. So we have 4 output, you can see 3 taps and another supplementary water flow. So 4 output. In the input side, what I am receiving, which things is actually helping me to decide on my states or decide on my output, and those are your sensor read S1, S2, S3. So you have 3 input. So input and the resulting output are simple, like not simple, but yeah, here we can quickly find it out. But deciding on states are important, you need to find out. Okay, so from this table you can easily say that here we have 4 state actually. One state is that A, whenever we are below state A, let me change the color, yeah, state A whenever we are below S1, state B whenever this, or C or D. You are perfect. You can go like that, and I can also write like this. Wait, I can say that here this is state A, state B, state C and state D. I am trying to attempt the state transition diagram, because state transition diagram will help you to decide on your that functionality, that when my next stage will arrive, what is the expression or what is the condition to get the next state. So let's try it out. No issue. Now if you are at state A, so what does state A mean? Means you are below A, below S1, right? So anytime you are below S1 and you are getting input, and also how we are denoting input are your S2, S3 and S1. So this is 3-bit input, right? So you can get input like this, or you can get input like this, or you can get input like this, or you can get input like this. I'm just using these states. So now anytime you are getting 0 0 0, all 3 sensors are not high, imply you are still below S1 sensor. So if I am below S1 sensor, means I am still in the same state, or I am still in the state A. Just remember, state A means below S1. Okay, so then if anytime I get that input, I will be here only. So 0 0 0, perfect. Now anytime you are at state A, can you receive a input of 1 1 1? Can you? Actually no, because input 1 1 1 imply your water level are here, like you are above, your S1, S2 and S3 are all submerged under water, and you are above S3. But before my water go there, for sure I'll reach here, right? And reaching here imply I'll get a signal of 0 0 1, because my S1 will get triggered. So therefore I can't escape this input and get directly 111. So therefore I won't consider this as a valid input, but this could be a valid input. So I can write here that here anytime you received a 0 0 1, so if I am receiving a 0 0 1, then where should I go? What should be my output? First of all, let us see, if I receive a 0 0 1, then in which state I'll go. So the state I'll go, for sure it is B. So anytime my S1 got activated, imply I am here in between S2 and S3. Oh yeah, so therefore I'll go to state B. So I can directly write that here, go to state B anytime you received a 0 0 1. Now the question is that, okay, I'm going there, but what any output change it would be there. Okay, anytime you are at A, and you are receiving 0 0 0, what would be the output that time? I just missed that scenario. So anytime you are at 0 0 0 means all the sensors are deactivated, imply I will have a output of turn on my tap 1, turn on my tap 2, turn on my tap 3, right? Also now if you are going to 0 0 1, you are getting a input as 0 0 1, then what would be your output? You just remember, you are going from down, this scenario here, you are at point B and you are going at point it is confusing, let us choose this point X. So you are going from point X to point B, right? You are going from point X to point B, imply previously it was empty, not empty, but yeah, below S1, and now it is going above S1. So that time your output would be F1 and F2, only 2 tap would be on. So I'll just write F1 and F2, perfect. any other state can I receive anytime I am at like input anytime I am at A? No, I can't get 0 1 1 also. 1 I have already shown I can go there, and if it is 0 0 0 then I would be here, and this, and we have these 4 input combination valid combinations only. Okay, now let us assume in state B what would be happening. So anytime you are at state B means you are at point B. This is my point B. I am in between S2 and S1. Now here again the same question, can you get 111 as input? No, 111 you can't get 111 before getting a 0 1 1 as input, right? So we need to consider with 0 1 1. So let me consider. Okay, now if it is 0 1 1 imply you are going from B to C, you are going from B to C, right? And your state would be C. C state means you are between S3 and S2. So I'll just go here if it is 0 1 1. Now it is very important, if I am having an input 0 1 1, I am going to see what would be my output. So the output would be, because you are going from a down position to up, like your water were below, your water were at point B and you are going to point C, so that time only F1 tap would be activated. And now 111 is not possible, but if you get a input combination of this one 0 0 1, so if it is 0 0 1, which imply you are like your water level going down from B to point X, from B to point X, or you are previously in higher position but you are going to downgrade position, your water getting reduced, which imply for sure you will again be in state A if I receive a 0 0 1, but because I was at upper level and in the next instant I'm going at a down level, so therefore for sure your F1 and F2 would be triggered, but also your delta F will also get triggered, right? So I'm not gonna complete this state diagram here, because the main motivation is not to complete this state diagram but to show you one thing, and that is, see here what is happening, you just see, and that is your output. These are my outputs. Your outputs are actually dependent on, for sure on state, which state I am, but also dependent on what is my input, right? I was in state A previously. If I get 0 0 0, then this is my output, but I'll again get back to state A, but if my input was 0 0 1, then my output would be different. That means the output getting influenced by both state and both the input, and that is a what type of state machine is that, and that is nothing but your Mealy state machine. So this is a Mealy state machine. Good thing about Mealy state machine, and that is you have less number of state, but the complexity of Mealy machines are more, because now you need to consider your input also to get a output. Previously if I am a state A, I know, like independent of any input, if I am a state A, my output would be that only. Like previously all the questions we are doing that only. But this is like, if we go with a Mealy approach, then there would be little complexity in design, but good thing is that state would be reduced. But the good thing, or you can consider bad thing also, and that is in this question actually they said you need to model it as a Mealy model. And why I started with a Mealy kind of approach, because I want to show you that any Mealy machine can be converted to Mealy machine, and vice versa is true. And the conversion is very important. Any exam, any interview, there might be simple question like that, and you need to have the ability to convert from one to another and vice versa. Also advantage, disadvantage. I am not discussing all of those things because this is a concepts of digital electronics, but I am giving a hint that hey, this is an important topic. But if we consider of Verilog, then let not deviate much today. So to convert to like Mealy to Mealy, what I gonna do, I gonna increase my number of state. How I gonna do it, let us see. So for sure for a your confusions are not there, that a when anytime. Okay, let me draw one thing. So this is your S1, this is your S2, and this is your S. We are sure with two state, and that is state A. Anytime I am below S1 it would be state A, and anytime I am above like my sensor 3 it would be state D. Previously I said this is as B and this is as C, but now, so here actually I split my states. So I'll split my state to two state, B state, and that is I'll say one as B0 and another as B1. Why? So we will reach to V0 state any time our water coming from previously higher position to a downward position, and we will reach to state V1 anytime we are reaching. And just hold on, if you're getting confused, don't worry, after this problem solved you would be in a position to solve it. So just be patient and follow me. Okay, so B1 is that anytime you are reaching from a down water level to a top water level. So I am previously at state A, I was at state A, and now I am reaching to a location which is in between S2 and S1, not in exactly in the middle, in between, because in the question also they have written in between if it is. So I have splitted my previously B, who like B doesn't include this water level, it is coming from top to down or down to top, but now because I want to design it as a Moore machine, I need to split it up. C also, for C, and it is you have your C0 and C1, and going with similar convention, anytime I am coming from a top water level to down in between S3 and S2 it would be C1, and anytime I am going my water going from in between S3 and S2 to above S3 it would be C1. So now how many state I have? I have 1 2 3 4 5 6, and 6 state can be encoded in different way, but we will go with the simple way, like minimum number of binary bits. So for encoding 6 we need 3 binary bits, so we need to encode them. Okay, so now if this is clear, let us try to build this state diagram. So here you have A, and you have your B0 state, B1 state, and here I have D, I have my C0 state and C1 state. State transition diagram, I said na, if you determine your states and you determine the state transition diagram whenever you are in the initial you are going with FSM problem, then mostly 80% of the problem is solved. You need to be perfect here, you do anything wrong here, all the your solution would be wrong. Okay, now again let's go back to our, if I'm at A, I can't get 111, yeah. And now the thing is that previously this was my state diagram. Here I was not sure about my output because my output was dependent on the state and on input, but now I can be sure that hey, anytime I'm at this state I'll get this as my output irrespective of what is input. So let me just write down the output. Anytime you are at B0, what would be your output? So let us go, what is B0? Like we were defining, your B0 is anytime you are coming from top to down, like you are at higher position, your water was at higher position, and higher position imply, see here, higher position imply B0 is there, higher position imply you were at between S3 and S2 and now you are coming down. So anytime I am coming from higher to down, that time for sure my F1 F2 tape will go up, and additionally my delta F will also go up. So which imply anytime I am at F1 B0, my output would be F1 F2 and delta F. And anytime I am at B1, which imply I was previously in a down position, my water, now it got filled up a bit, like I go above my one of the sensor, so that time only your F1 and F2 would be high. Likewise, if it is C0, you are coming from top to down, so that time F1 and delta F will be on, and anytime you are at C1, that time only F1 would be on. Anytime you are at D, no tap would be 1, and anytime you are at A, your F1, F2 and F3 would be 1. So see here, it is so simple. With the state I know the output only. Now my main work is that how to transition from one state to another state with the help of input, and output is already defined here. Now you just concentrate on both the thing, left and right. Right side you have your states, your water level, and left side I want to design my state transition diagram. So from A to B0, when you will reach? From A to B0, when I will be reaching? And actually I can't reach from A to B0, because B0 I can clearly see that here it is anytime I am at water level S3 to S2 in between, right? And one thing you need to, if you are confusing, then just be sure that here C0 and C1 maybe implying the same water level, but they are differentiated with respect to their previous water level. If I coming from top to down, then it is C0. If I'm going from down to top, then it is C1. So don't be confused. So B0 I can't reach from A, but from A I can reach to B1. And when I'll be reaching, when I am at A, my all three sensors were down, but anytime one of the sensor come alive, I'm sure I'll reach at V1, because V1 imply you are going down water level to top water level, and A is my down water level, and anyway V1 is a top water level. So that is perfect. Now anytime you are at A and your water level increased by a slight, but you haven't reached S1, S1 is not set, you are still at 0 0 0, so that time I'll be at state 1. So 0 0 0. Here I don't have any question of what's the output, because outputs are already defined. If you are at A, turn on your F1, F2 and F3. Oh, F3 I haven't written here, it is F3 also. And anytime you are reaching to B, you are reaching to B1, then turn on F1 and F2, and we are sure that B1 means I was in down, I came up. Okay, perfect. Now can I go from B1 to B2? Is there any relation from B1 to B2? B1 to B0? Probably not. There is no relationship. Okay, no issue. Now if you are at B1, if I am at B1, I'll go for B0 a little later, but okay, if I'm at B1, I can go down, right? I can receive a 0 0 0 signal. So if I received a 0 0 0 signal, then I'll again go back to my state 1. But if I'm at B1, and water rises a bit, but it doesn't touch my S2 sensor, which imply I am still getting a 0 0 1 as my input. So that time I will be in the same state. So 0 0 1. I can also receive a 0 0. I can also receive a 0 1 1 anytime I am at B1. And if I receive 0 1 1, which imply I am going to a position C. C could be C0 or C1. I will determine that later. But I can reach to a position between S3 and S2. But I was at B1, which is below the position. So that means previous water level was below. I am going up, and which imply I can only reach to C0, because C1 imply that my water level from down to up, it came to up. So C1. So I can only reach from B1 to C1 anytime I received a 0 1 1 as my signal. Now after reach C1, again here same thing. If I receive a 0 1 1, I'll be at the same position. But if I received a 1 1 1 as my input, then where I'll be reaching? For sure, if it's 1 1 1, then I'll go to my D. So I'll go to my D. Now whenever you are at D and you are receiving 1 1 1, you will be at D only. But from D, if you received a 0 1 1, which imply you are at D, top level, you are going down. So top level to down imply I can't reach C1, because C1 is when down to up I'm going. So that means I'll reach to C0, 0 1 1. If I'm at C0 and I received a 0 1 1, I'll receive there only. But anytime I'm at C0 or the C location, or in between S3 and S2, my water can go down to between S2 and S1, and when I go in between S2 and S1, imply my input would be 0 1 1. So anytime I received a 0 1 1, I'll go to B0. Why B0? Because C0 was a top position. From top to down I'm going. Okay, simple. and if I received a 0 0 1, so I'll be at B0 only. But anytime I am at V0 and if I received a 000, then I can go back to my A state. I hope I have covered all the scenario here. If we miss any of the age, any of the transition age, our question answer would be wrong, right? So therefore it's very important. You can double check, you can again do it, and be sure that hey, all the equations are maintained here. So one way to debug is there, just write down all your input, what are the input you can receive, and see if all the valid inputs are taken care in all the states. So anytime I'm at V0, I am between S2 and S1, so I can't get 111 for sure. I can get 111, I can get 001, I can get 000. So I have considered for 000, I have considered for 001, but what about 011? So anytime if I receive a 011 when I am at state B0, so 011 means my sensor 2 is also submerged underwater, but I am going from down to top. So from down to top, which imply you are going to C1. So I will just from here, I'll come here, and if it is 011, so B0 is taken care. In B1 I have taken care for 001 here. For B1 I have taken care of 001 00, but what about 011? And 011 actually give back to you on C1 only, because you are again from down to top you are going. Okay, so our B0 is also checked. Now let's check for C1. So in C1 I have taken care of 001, 111. So anytime I received a 001, I will again transfer back to B0. It is little confusing, but it's okay. And the good thing is that every time you don't need to design this state transition diagram. Actually, when I'll go to Verilog code, you will see it's little simpler than this actually. But here, because we are just beginners, so I am trying to show you how state transition diagram would look like. Okay, so from C1 I can only reach to B0, because B0 imply I'm going from top to down. So and for B1 we already taken care of 3 input. For C0 let us see. So whenever you are at C0, same again, you are in between S3 and S2. So anytime I have C0, I have taken care for my 001, right? I have taken care for my 011 and 001. But anytime I am at C0, there should be a possibility that my tank got full, or I get a 111 as my input. So anytime I get a 111 as my input, I'll reach to D. Okay, so I think a lot of things, most probably it is 80% done, but don't be afraid. I said, like, if you done anything wrong here, then your Verilog code would be wrong. But if you design your Verilog code only like considering this, then it would be wrong if you done anything wrong here. But the good thing is that we won't be going with K-map type of solution. If you want to go like K-map type of solution, then you need to convert this state transition diagram to the truth table or excitation table from their K-map. It's a long way path, but we won't go like that, and actually we won't use this state transition diagram anytime we are going for Verilog code or FSM. So let me go there and I'll show you that. So first of all, we need to decide on our what I said, our states. So we know we would be having 6 states, and those 6 states will have their encoding. So the first is D when we are at top. So D equal to let us say it is 3-bit. C0 is anytime I'm coming from D to down, so C0, C1, and after that we will have our, so this is the state encoding we will do. And if you want to be more sure, you can just comment also down that here above S3, and this is between S3 and S2 when see from here also you can see C1 C0 when previous level was D0, when previous level is up. Likewise you can comment down for your future reference, but for now we'll stop here. and then the main thing, and that is that combinational block for your next state. But again we need to define for our next state. So first of all, state, and we will define it as register of how many bits? 3 bits. Why is 3 bits? Because it's sure our states are of 6, so we need 3 bits at least. So state and the next state. Okay, now we will start our always block, which is a combinational always block, and those who are followed me, they are knowing what I'm writing here. If not, you can just revise your Verilog concepts. 30 days of Verilog, the part 1, where 30 days of Verilog course. So there we have discussed this thing in a great depth, that why when we are in a combinational block logic, why we use star as a sensitivity list, what the use of begin and end. Those things are already described in detail, so you can go to that playlist, 30 days of Verilog coding. Okay, now we will go with case statement. In our previous problem of FSM, we have seen already that hey, we can go in KMap way also. There are other things also, but case is the most good way to go. So I'll write state. So now anytime I am at state A, now if you have a rough diagram of state transition diagram, it will help you to visualize it. But for our case, actually this is enough. This diagram is enough here. This diagram is enough. Actually state diagram is not so required here. So if you are at state A, and I know anytime I am at state A, I can get 3 input actually, not 3 input, 2 input only. I can get 0 0 0 or 0 0 1. So first of all, I'll check for if it is a 0 0 1, and actually you can see from here, and that is your inputs are coming from here 1 to 3. So S1, S2 and S3. So it is like that. You have your S, and it have 3 bit, right? So 0 0 0 is all 3 sensor are down, 0 0 0 1 1 sensor is up. Or you can just check if your first bit is up or not. Why first bit is denoted with the index 1? Because you see the definition. In the definition we are using it as 3.1 in the vector. If you are confused with this, check out the vector episodes. Okay, so it starts from index 1, so therefore you can just check your index 1. Now if it is 0 1 1, means we are here, right? We are here, somewhere here. So that means I can just check my second bit is high or not. Yeah, literally checking, I need to check S2 and S1, both need to be high. But from our general sense, we know that if my S1 sensor is high, for sure it implies S1 sensor is also high. So therefore I can only check S2. And for 111, I can only check if my S1 is high, S3 is high or not. So that thing is clear, right? So here I'll check first if my S1 is high or not. If my S1 is high, that means I need to change my state. So previously I'll write here next state equal to. So if you are at A, you are down. So from down you are going up. Your S1 sensor got set. Imply you would be on B1. So my would be B1, or else I'll be at same state. Perfect. Now anytime you are at, here we have used small case. This is a little confusing actually. Let me make it. Now anytime you are at B1, right? So in B1 actually you can receive 3 input 000, 001 or 011. So if again next, okay, so if it is 0 1, means only S1 sensor is up. I am still between S3 and S2 sensor. I am still between S2 and S1 sensor, imply I will be at B1 only. Else which input I can get? I can also get a S2. So if I receive a S2, imply I am again going down to up, so my state would be S1, or else what else I can get? I can get a S0 or all the 3 sensors are down, imply I'll get back to my A. Likewise B2. Now again, when you are B2, you can receive three input actually, and if I am still at S1, imply I will be at B2, not B2 B0. I'm extremely sorry for this confusion. Okay, so if I don't get a see what I am doing. Yeah, so now if I don't get this, then I can get a S2. So if it's S2, then I'll be at C1, or else I'll go down to A. And likewise, let me go do it for C1 for you. After that, you need to do last 2 line. Now anytime you are at C1, you can again receive 3 input. So now if I receive a input of all the 3 inputs are done, 1 1 1, then I'll go to state D for sure, or else I can also receive the same S2 only. So if it is S2, I will be at C1. I'll go down to B0 or B1. Tell me. B0, because C is the uppermost layer, so upper to down I'm going. And for C2 actually the same, just let me copy it. Here is same, just here it would be not C2, yeah, I'm sorry, C0. It would be C0 here. Okay, and this would be B0 only, because again you are going from C0 is also up to down. And lastly we are at D. So anytime you are at D, how many input you can receive? I think 2 input only. So first of all, let's check for S3. If I receive S3, I will be at D only, or else you just see here, I can receive all 3 or 0 1 1. Other outputs are not possible. So that means or else I'll go down. Where I'll go down, C0 or C1? I hope now you are clear. It would be C0 only, because top to down I am coming. Anything possible in D? No, I think D only have 2 input only possible. And it is a good like design practice, and it is giving a default state. Your next state would be undefined. We don't know what would be, so I'll just write, and your state is of 3 bit, so 3B and then XXX, means it is undefined state. So good thing has been done, actually the main thing of this problem. But now we also need to define for our transition of D, right? Like transition of your one state to another state. So that is the step, like this is our step A. Now we will go for step B, and then step C is the finding output. And if you are getting a little confused, then I'll strongly recommend you please subscribe to our Verilog practice series 2, where actually we started in the FSM, like simple problem we define, or we splitted up FSM problem solving in simpler way, like step A, step B, step C. And then this is not a complex problem. More complex problem are in the future gonna come. So if you want to enjoy this type of problem solving, practical Verilog problem solving in FSM, so please subscribe it. It's still available in a cheap rate. It price might increase, so I will come you there. Okay, let's get back to the problem. So now I'll write my always for what? Always for my transition from current state to next state. So this is like, this would be a sequential block. So I need to write post age of clock. Clock is defined or not here? See, clock is defined, CLK. Okay, reset, yeah, reset is also defined. Synchronized reset or asynchronous reset, active high, synchronized reset, that yeah, okay, it's a synchronized reset. So if it is synchronized reset, we won't give it in a sensitivity list. Begin and end. Okay, and I'll write, it's simple, No, first of all I need to check for my reset. So if it's reset, and anytime I'm reset, what should be the reset value? State equivalent to water level had been low for a long time, no sensor asserted, and all 4 output asserted. Okay, all 4 output asserted. Okay, all 4. I said now we have 4 output, 3 tap, another is supplementary flow. Okay, so if it's reset, then my next state would be A. It would be next state, not the next state equal to state. Okay, so this is our step B. Step B is also done. Now the step C, and step C is your output, and you need to be very considerate here. We have 4 output here, and therefore again we will use a switch statement here. Okay, so I'm just like case statement here, and again for case, for sure I need to have a always block. And yeah, I have ended this one, but I haven't ended the always block. So let me copy this. Let me this end is for this begin, this is for this. Okay, yeah, here some confusion or something there. Okay, so if my state A and these things are not required, let me cut. So if I'm state A, and just see what are your output. These 3 are your output. Okay, so I'll write them in sequential order. How it's written, FR3, FR3, FR2, FR. Comment down which Verilog technique I'm using here. FR0 and delta F, I think DF, DFR. This is called your concatenation, I guess. Okay, so this is equal to 4 bit 1111. So if I'm at A, then all my 4 output would be high. If I'm at point A, imply I am below all the sensor. So therefore all the 3 tap would be on. I think F0 is not there. Yeah, F3, 2, 1. All 3 tap would be on. Also my supplementary tap need to be on. Actually it's written here also. Yeah, here it's written below, and for a long time no sensor asserted, all the 4 output asserted. So if I am A, so all the 4 output would be asserted. Likewise, if you are at V0, V0 means you are going down to up, so delta F would be on, but your F3 would be 0, right? Here B1 means you are going top to down, so your supplementarily would be off, and also the F3. If you are at C1, first 2 tap would be on, only 1 tap would be on, and C1 is again you gone from down to top, which means supplementary would be also on, and for other case supplementarily would be off, other 2 tap would be off, and if you are at D, all the tap would be off. Oh, and default would be 4, and here it would be again this. Okay, so case is there, and case, I guess I am doing a lot of syntax error probably. Yeah, this is the case. See, always block also need to be there. And always need to have a begin, because here multi-line things we are doing, so begin and end is necessary. So I hope if I am not doing any syntax error, then I should get a correct result. Okay, yeah, let me copy all, yeah, just to be safe side, and submit. I hope we'll get a correct answer, and it's really a long problem. Oh, at line number 11. Okay, I got the issue actually. Anytime you are defining a parameter, see, it's a 3-bit parameter, right? So we need to write that it's a 3-bit parameter, and then it should be comma, this thing need to be comma, and then here parameter ended. I hope this is the only 20. This is the only syntax error probably we have here. So submit it and let's see. Now at line number 25. Oh, I think we missed something. Oh, we have forgotten next state here. Next line number 39. Yeah, I was talking with you, that's why all the syntax error are happening now. See guys, what's the blunder I have did. This should be this. Okay, I think we need a comma also here. Okay, let me put this commas here. Okay, I think this time we'll get answer, at least not a syntax error. Can't resolve multiple consistent next state dot a in line number 30. This should be state, bro. State. Okay, we got the answer, but there are mismatches in f3, f2. Okay, f3 is perfectly matched, f2 also not matching. Yeah, we can debug it from here, but good thing would be just go here and revisit if we have doing something wrong here. Actually, I think this delta fr will only go high anytime we are coming from top water level to down water level, and our b1 is actually we are coming from down water level to top water level. So probably this would be 0 and this would be 1 here, this would be 0 and this would be 1. I think that is the only thing. Yeah, and another suggestion would be if such kind of things are a little confusing, you can go with if else way also. But here I can see one issue, and that is, see, if it is s1, then I'll stay at b1 for sure, or else I'll go to down. Yeah, actually in HDL VS environment our hands are a little tied. Actually, we haven't designed the verification environment. This look perfectly fine for me, but let me do some changes here. Let me check for s2 first. If it's s2, then it would be c1 for sure, or else if it is s1, then it would be b1. We'll be stay at b1, or else we'll go to a. Yeah, that is looking fine now. And here also, if it is s2, then you go to c1 next jump, or if it is c1, then you stay at b0, or else go to down. Here, yeah, verification is a little tough because we can't print b0 separately, b1 separately to see how their waveforms are. So therefore debugging is a little tough in HDL bits environment, and we got a success message here. I guess our previous solution is also perfect, but due to their how they have designed the verification environment, probably some issue were going on. So you just don't worry. The main thing is that the concept we need to learn, right? And this problem has given us really a good insight into the problem, right? So before I end, I'll again request you can just visit my website www.whyRD.in and subscribe to Verilog Practice Series 2 to solve all this problem along with me. And I'll see you in our next video. Till then, tata, bye bye.